Hi everyone, I'm Mark. I have been coming to this meetup for a long time now, maybe 5 or so years. But this is the first time I'm speaking, so I'm really excited about this. However, my talk will be a little bit unusual, as you maybe already understood from the title, because here usually people speak about wins, about good things that happen in the world of data. How they created some project that made a lot of value for the company using machine learning, almost recently by training AI agents to evaluate other AI agents. I, however, would like to talk about the other side of this whole data business. I would like to talk about this situation. I would like to talk about failure and how so many different failures actually trace back to just one single point at the very start of the project. But I would like to begin with sort of a collective confession, if you will. I'll go first. So I've been there many times, and I've seen even more situations like this happening around me. Things like goals that get moved in the middle of the projects. Things like releases that get canceled or delayed. Or even projects just quietly going to die due to nobody's fault, of course. And I suspect that I'm not alone, that everybody who works with data has been there. But I would like to level with you. So let's have a poll. OK, I think it's coming down. We have 47 votes. That's pretty good participation rate, actually. And we can see that 58% of people are traumatized and don't want to share. But hey, the 24% that do, like there's going to be my contacts at the end of this, please share. I love those stories. And we have 4% of people, 4% of people who are perfect. It is really humbling to be in the presence of perfection, but for the remaining part of the audience, which has ways to go, let's come back to the presentation and answer the question of what is that one point of failure which I mentioned a few minutes ago. Well, it's just the good old documentation, or to be more precise, it's the lack thereof. The thing is, here are two facts about documentation. First, most people agree that it's useful, that it's important. And the fact number two is everybody absolutely hates writing it for some reason. Now, why is that? I guess everybody has their own reasons. I'll give you my top 3. And the number 1 is, I think, the pressure to deliver. So usually, the results in any given project are wanted yesterday. And in the machine learning field, at least, writing and documentation is rarely considered to be progress. Second is, writing docs is boring. Data science was once named the sexiest job of 21st century. And when you hear that, you probably don't think writing docs, right? And finally, I'm kind of still waiting to meet somebody who was promoted or got a raise just for a beautifully written design doc, so why bother? If you're still not full of motivation to embrace design docs, I picked a quote from the book for you. This is the quote. Now, most of the things that promise you 100% results are scams. But in this case, it's not, really. For sure. Cool. Now that we are all motivated, we basically don't have time to learn how to write design docs in this one talk. And also, that would be a pretty boring lecture. So I thought we would do something else that's more fun instead. Namely, I'm going to present to you a few stories of real-life stories of projects failing Some of them are going to be from the book. Some of them are going to be from my experience. I'm not saying which ones are which. But yeah, we are hoping to get two things from this. First, watching other people fail is fun. And second, we are going to collect a few reasons why things went wrong. And then I'm going to show that they all could have been easily avoided just by writing a design doc. Let's go. Story one. Story one is about a bank, and banks lend people money. However, sometimes people don't pay that money back, in which case the bank usually wants to do something about this. One of the more peaceful options is to send a reminder to the debtor, like, you have to pay. The problem is, you don't know how people are going to react to such a reminder. They can react as you want them to, by paying you back, or they can react by leaving the country. That would not be nice. This is where this metric CR conversion rate appears. And this is basically what such systems are built to optimize. So such a system was built. You put in the data on the client, a conversion rate, like a probability of the client paying you back upon reminder is predicted. And the system was good. Like, it was so good that the vice president of the bank wanted a personal presentation of the system, which is where the kind of ouch moment happened. Because during the presentation, the VP kind of cuts off the data science lead and goes, cool CR, but what I want to know is actually why people are paying us back. And that's bad, because the question of who is going to pay us back is extremely different to the question of why those people are going to pay us back. So in this case, due to an incorrectly set goal in the very beginning of the project, the team kind of just had to go back and, well, completely redo everything, which is sad. Even sadder is that this was not even the first failure of this project. Another one happened a little bit earlier. And so in every model's life cycle, there's a moment where your model is good on paper or good offline. This means that if you train your model and test it on the historical data, on the old data, things are looking good. And this is where you go to production and you try to see if you can make some money, extract some value from the model. And yeah, in this case, offline CR was 0.9, which was miles ahead of the baseline that they had at the moment, which had CR of 0.5. Yeah, that's a fantastic gain offline. But when they deployed this, they saw 0.35, which is terrible. It's worse than the baseline, and it's almost 3 times worse than what they were hoping for. Yeah, so what could have gone wrong? Any ideas? OK, I'll just spoil it. Many things, like this can happen due to many reasons, but in this case, this was all about measurement mechanisms, how this CR was measured. What the data science team was blissfully unaware of was that between the fact of debt repayment and that fact being visible in the company database, there were 3 whole days. So yeah, I mean, you can imagine all kinds of scenarios where this changes, this skews the value of the metric, and it stops reflecting the actual reality. For example, somebody could pay their debt on their own, then receive a notification because the company still thinks the debt is not paid. Then they ignore this, and then they become a false negative, basically, in this conversion rate measurement method. So yeah, measurement methods are important. It's important for the data team to talk to the infra team and vice versa. But let's leave this bank alone and go instead to a certain car rental company, where it turns out people just didn't talk to each other. Communication, hashtag communication. What was the project? The company set out to optimize its landing page. Very classic idea. Optimized landing page equals more conversions, equals more money. So you have to, present what you have in the best possible manner. Specifically, the goal was to make the most out of the top row, which is just 3 cars. So that's only 3 positions where the attention of the customer is at its highest, and therefore every position matters. So a system was developed, it was deployed. So far so good, until in a few weeks, it turned out that a lot of the ML system's recommendations were simply ignored, in the sense that they were not shown. Why? Because in the business department of the company, for business reasons, business people decided that some cars are just not allowed in the top row. That's just how it is. And yeah, I mean, it's been said times and times again, communication is important. Probably thousands of books about how to communicate well with people, and this still happens. But yeah, let's stay with this company for now and look at another project that they had. This time, the idea was to optimize staff planning for customer-facing branches. So a branch is where you go to actually pick up your car from the agent. And the idea here was that you might want to optimize the number of agents per branch at a given time. Why? Because if you have too many agents, well, you're paying them for nothing. They're just sitting there. If you have too few, it means that people are going to be coming, and people are going to be waiting. And that's a bad customer experience. So what you will want to know in this case is the expected demand at a given branch at a given time. A forecasting system was developed. It was like, this problem is actually similar to the one that we kind of saw before, in the sense that models that were looking good on paper didn't look good in prod. However, this time this discrepancy comes for a different reason. Also a very simple one, namely optimizing the raw metrics. In which sense wrong, right? We all know and love standard regression metrics, root mean squared error, mean average error, whatever other average, absolute, etc. error. But the problem is that those metrics usually don't really reflect the business needs, and improving them does not necessarily mean that anything practically improves. So why do we do that? Well, because that's fast and that's easy, right? And people like fast and easy, except for cases where they don't. Story number 5 is about a company that was trying to improve an already existing model that was predicting travel time estimates. Improve by stacking another model on top of it, which would produce corrections for predictions of the first model. Sounds complicated, right? Sounds like it should be done by an even cooler model, even more complicated, even more features, etc., etc. Who here who works for ML has ever skipped the baseline and went straight for the fancy algorithms in their job? Okay, we have like, what, 5, 6 honest people? That's pretty good. But yeah, this is a tale of wasted effort, because in this case, months after the complicated model was deployed, someone had the idea, what happens if we just take the median of the target on the training set and use that? Well, the answer is we were going to get predictions which are statistically equivalent to those of the more complicated model. So yeah, that was awkward. The moral of the story is do not skip the baseline. It's a really good idea to have it. Cool. Final story. This is a good one because it shows that it's not all about fancy models. It's not about math. It's not all about being smart. It's also about having proper processes. What do I mean? Well, in this case, we are talking about a small startup which has a pretty small data team, only a few models in production. And one of them was like the real money maker of the company. So improving it was important. So important that basically the whole data department, which is like a couple of people at that time, was really dedicating a lot of time to improving it, to trying to beat the champion model, running A/B tests. Yeah, important model. At some point, logically, they succeeded, and everything was looking amazing. You know, they already did the company-wide kind of announcement, like, hey, big news, we have sort of a breakthrough here. Already a meeting scheduled where the data team presents what they did. CTO says like, wow, that's so cool, you all get bonuses and stuff. And a few days before that meeting, someone had the, well, in an unfortunate event, somebody double-checked the predictions. And it came out that this amazing result was just a kind of a sneaky illusion. It wasn't actually even there. What was it? Well, what it was is, due to the lack of proper monitoring, due to the lack of proper reporting procedure, the earlier iterations of the challenger model, so their attempts to improve the current model, just overrode the results of the champion model. So what they beat was not the current champion, it was just a kind of a shitty version of the challenger. So there was no result. So yeah, I mean it's a tough one because there was a lot of hopes involved in this one. Yeah. Right. That was all the stories. So what? We have seen 6 whole different reasons for why perfectly smart people which really went to real universities, had real experience, etc., failed miserably. In fact, maybe you are even wondering if ML projects even work at all at this point. And the answer is, well, yes, they do, provided that the groundwork is done in the beginning of the project. This is what design docs are for. They are bringing rigid structure into a difficult, chaotic process. Don't try to read it. This is a lot of text. The point is not to read it. The point is that this pretty generic template for a design doc, which will fit 90% of the projects, it would have a section dedicated to each of these random failures. And what does that mean? Well, it means that it will force the people who work on it to think about this, to write it down, and thereby drastically decrease the chance of actually walking into this nonsense. Because just think about it, like all of these things, they're not some ultra complicated, impossible to anticipate, conundrums. They're just silly mistakes. They happened probably because people who were developing them had a lot of things to think about in this project, technical side, business side, all the other sides, whatever else. So they just forgot. So yeah, that is what design docs are for, and I hope this short presentation convinced you already that it is important to have design docs. If not, it's okay. At least now that your projects will fail by choice. I also promise to give you a few pointers of where to start if you are indeed interested. So let's do that. There will be a link in the. There's no. Cool. So tip number 1. Pretty much what we were talking about this whole time. Doc first, code later. Like, be like this guy with blueprints, not like this guy who built something that's going to be tossed because it's weird and like it's not functional. A natural question to ask is like, well, how much time should I take to write this document? My boss is breathing down my neck. And for that, 2 weeks is a pretty good sort of baseline. I know it sounds like a long time. I know. However, try to view it as a time investment instead of some pointless bureaucracy. See it as a 2 weeks now or months, or in some cases years later. Kind of like a deal proposal. And to be honest, I would take the deal because it's a damn good deal. Yeah. Tip number 2 is that everyone who is involved or affected by the project should contribute or at least proofread it. And when I say everyone, I do mean everyone. Last movie reference. Yeah. Why, right? Why? Because at this point, context is key. You have to understand why you're building what you're building and how you could do that, how you could achieve that. Because these 2 things are going to shape the what you're going to build. Which kind of brings me to the next tip, which is to start in the problem space and only then to transfer to the solution space. This whole problem space, solution space is a pretty known concept. Definitely didn't invent it. Even the guys who wrote this book didn't invent it. I do believe it's very popular in software engineering area. Who here has heard about it at least? Oh, I see. Well, yeah. So, but yeah, it's a like pretty deep thing which is very roughly summarized in this Venn diagram. It could be basically this could be a separate presentation, so I'm just going to leave it here. Feel free to explore it on your own. Next tip is that design doc will change, like a lot. So do not chase perfection. Do not try to do it once and for all, because authors provide basically this typical life cycle of a design doc. And as you can see, whatever you write in the beginning, it's going to be mostly rewritten probably when clashed with, life. Okay, final tip. You may be wondering, and I think I saw a few people taking photos of the the table of contents. Where can you get this, structure? I do recommend reading the book. It's I try to read books about to develop professionally, but if I had to read just one, it probably would be that book, because those guys actually lived through all of this. And if you don't have time or you don't want to read a book, there's going to be a QR code in a few slides which links an open source repository from one of the authors, so you can just kind of steal it from there. Cool. We're almost done. Just a little bit of exclusive material for you. When I was preparing for this talk, I reached out to both of the authors for sort of a slide-sized piece of advice for anybody who's about to start writing docs, which I hope is all of you. And they replied, which is really nice of them. So let's take a look. Valery says that a true mark of a good design document is killing a doomed project early so as to waste paper instead of time and money. I think this is super deep, because to be honest, probably a lot of machine learning projects which are currently in production should be removed from production. They are a way too complicated way to solve a problem that can be solved without any machine learning at all. And another kind of like what this implies is if you start with a doc, you are more likely to notice that you either should not do this project because it seems way too complicated for what it brings, Or you cannot do this project because it requires maybe technology that your company doesn't have. So all of these things are best discovered in the first couple of weeks of considering to do the project, as opposed to after a few months of actually trying to do this. Arseny said even more things. I kind of tried to synthesize them in 3 sentences, but yeah, a lot of good advice. Thanks to Arseny for this. The first one is basically that this is the advice to use the design doc as a communication tool, as opposed to something that just has to be ticked off as a part of the bureaucratic procedure of creating projects. The second one basically reiterates that problem space, solution space thinking is a very nice kind of state of mind to be in when you are trying to solve a problem. So yeah, once again, I recommend exploring this. And finally, Arseny highlighted a specific section in the design doc, which, to be honest, I don't think I've ever seen anybody do, at least in my experience. And that's error analysis. That's actually taking the errors that your model is producing and trying to find patterns, trying to understand what is happening, why is it doing that. Yeah, that's much more efficient than tweaking hyperparameters and yeah. OK. QR codes. I link the design doc repo, which I mentioned, and also the book. It is not an affiliate link. It's just a link to in case you wish to read the book. Then we are done. If you want to be friends, or if you want to share some of your failure stories, please do. I love those. I think they are. I think success stories are interesting too. Okay, but failure stories are the ones that really make at least me grow. So yeah, do share them if you have them. Thank you for listening, and yeah, let's have questions. Oh,